Alright, so extension video. How do we make tSNE and kMeans data? I'm going to cover three different ways to do it. Firstly, I'll talk about how to do it in JavaScript and why we don't really normally do this kind of thing in JavaScript. I'll show you how you can do it on the web, and then how I actually did it, which is using Python. If you've programmed with Python before, you should be pretty comfortable with this kind of technique. If you're new to Python, it's a very simple language, it's very easy to read, and there's a million tutorials on the web on how to do it. There's probably even specific ones for going from, say, JavaScript to Python, if you're used to that. So, the reason we don't normally do this kind of thing in JavaScript is because it's quite a slow algorithm, especially with large data sets. We have thousands of tweets, and this algorithm needs to do a lot of iterations before it actually produces good results. So what I've got here is a little example of some Obama tweets, and I'm doing the tSNE here live in JavaScript. And you can see here what I've done in the code is we have a little limiter here of 100. So I'm only looking at the first 100 tweets, and I'm doing 500 iterations, which I'll talk about shortly. And so it's actually quite a small amount. There's actually thousands of tweets. I'm just looking at the first 100. And if we refresh this page and run it, you'll see over here on the console, it actually takes quite a bit to do these iterations. You can see them popping up there. And then we get our graph. So doing 100 tweets, not too bad. If we extend this to do all of the tweets, it's actually going to get so laggy that it might not even completely finish. It's definitely not something you'd want to be doing for your users, where they load your website and it sort of like freezes for 5 minutes while it does some calculations. That would be particularly bad on, say, a phone, where it's going to be even slower, it's going to drain a whole lot of battery. It's not something you want from your website. You can do it in JavaScript, you can do it on the fly, that's totally okay, especially if you're dealing with a really limited data set. So maybe you filter out your data and then you do some tSNE on the fly. So this would be cool because it could let your user, for example, do some queries, choose a query, they could type in climate, and then you could do the tSNE afterwards. But really, this is something you want to do beforehand and save it as a CSV. So I was working on this as an example for the tutorial. I realized it was getting quite complicated. It was very, very slow. And just working with this kind of data and saving it as a CSV is not really what JavaScript is for. But for completion's sake, we have it here. So I'm loading in the vectors. I'm using this tSNE.js library I found on the web. The link is here. I literally just downloaded the JavaScript file. This is the entire algorithm here. It's quite complicated, but I took it from the web. And this guy's function is quite simple. You make a new tSNE object. You pass in all of your vector data. Getting that vector data was a little bit complicated because we have the IDs in our CSV. So I slice off the IDs and map out all of the values as numbers, and that's the data we use. So now that we've set up our tSNE algorithm, we can run this .step function, and that makes the tSNE solution a little bit better. So every time you run this, it sort of runs the algorithm, and it gets a little bit closer to the sort of final solution. 500 iterations is a sort of a recommended amount. You could reduce this to be quicker, you could increase it to be more precise. And once you're all done, you can get the embedding out here with the getSolution function. So I'm using that embedding to actually make my plot just to visualize it, and you can see it gives you the data as these little arrays. So entry 0 is the x and entry 1 is the y. And so you're able to plot that out. This is where I got to, and I realized, hey, downloading this as a CSV is going to be weird, it's too slow, maybe there's a better way of doing this. Well, someone actually already built an app that does this for you in the web, and in fact I think it actually uses this same JavaScript library. So this is a version where you can do all of the stuff on the web in this nice interface, set it all up, and then you can download the data. This is also good because it's easy to play with some of the parameters. So tSNE takes in some parameters. The main one that actually affects things is called perplexity, and based on those values, you'll get different results. So you can see here, this is a live version of it. Every single iteration, you can see it gets a little bit better. The values spread out and find nice clusters, but it takes time, of course. So if you want to do some calculations, you can load it all up here and do it. But this is when I realized, the best way to do this is the way that I would do it myself personally, and that's using Python. So Python is good because it runs on my computer here. It's not great for making websites. You can totally do it with Python. But what it's really good at is working with data locally on my machine. So what I'm using here is the actual tSNE and kMeans algorithms from sklearn. So this is the website I was using during this tutorial. And so what I'm doing here is very similar to what I do in the other tutorial. I'm getting all of my vector data and I'm using it to train my tSNE. If you are scared by Python and this is all looking scary, but you just want to have a go at running your own tSNE, running your own kMeans, these are the lines to care about here. So this is where we actually do the tSNE, and this is where we actually do the kMeans. And you can see here for kMeans, I've said I want 8 clusters. So if you think there's actually 4, change this to 4 and have a go at experimenting. One of the great things about sklearn is that all of the different algorithms have got the same kind of pattern. So if I want to change this to dbScan, it's quite easy to come down here and change it to dbScan. I don't think dbScan takes in a number of clusters. It has some other values. I think it's called like EPS or something. But that's all documented. But it's all the same kind of pattern. We pass in the same format of training data into all of their functions. They all have this like fit predict or fit transform function to actually do the code, run the algorithm. So this is what I actually used to make the data for you guys. I did the embedding here. I did my clusters. I create an output file, which I'm writing to, and this is how I'm actually making that CSV. So I'm making the headers and then putting all the data together. So if you're new to Python, one of the really powerful things about Python is it's got this list comprehension where you can sort of do calculations over a whole list in one line really easily. And that's what I've been doing here. So this is getting rid of the IDs. This is extracting the IDs. Down here, we're getting out the rows and representing them as floating point numbers. So all this kind of stuff is really easy to do in Python. So if you want to have a go, I definitely recommend coming in here and changing the clustering algorithm, experimenting with some of the other embedding algorithms, and you can get them all from sklearn, as I was just doing before. So sklearn, scikit-learn is a very, very useful Python library. It's got tons of machine learning algorithms, including a ton of clustering and manifolds. So cluster, if you go to their clustering data, you'll see they've got all kinds of different functions you can use. Here they all are. And so you can experiment with some of the different ones. So I'm using kMeans. dbScan is pretty good. Looking at the user guide on clustering, it looks like for our kind of data set, perhaps this Ward one looks pretty good because our data set is sort of like these two examples here, where everything's together in a big bunch. And it says down here that warding, so ward hierarchical clustering, is good when there's many clusters, there's connectivity constraints, all kinds of, there's differences between all of these. So this is a good place to go and experiment with using them. And of course, there are examples here of, how the actual function works and how to use it as well. So if we go to the kMeans, this is literally what I did. I scrolled down and I said, here's how you actually use kMeans. You pass in a number of clusters, and here are all of the functions that you can use with it. So yeah, have a go at that. It's nothing too scary. And of course, like most Python code, you've actually got to run this using some kind of like command line thing. I'm sure there's a built-in way of doing it here in the VS Code. The easiest way is to make a new terminal and then simply to run the file. So Python, I called it tsne.py. You run this, and it will run your code. I'm in the wrong location. So yeah, I normally do this with a separate terminal window here. So yeah, you would run the code from the terminal. So let me just show you that just so that we can complete everything, make everything nice and clear. So we've got to navigate to where I keep this file. So I store it in InfoVis, week 11. I think it's week 11. Maybe I got that wrong. This is in my tSNE with JS file. And in here, I have, you can see it there, tsne.py. So I'm just going to run this command with Python, tSNE.py, and it's going to go off and do all of these calculations. This is using the Trump data. There's a lot of Trump tweets, so it's going to take quite a bit of time to run. And so that's okay. We just leave this running in the background. We don't want our users to have to do this experience. So we're doing this for them and saving that data out into this folder here. All right, so that's a little extension. If you're interested, I'll post this code in on the Canvas module so you can have a look at it. If you're new to Python, go and watch a video on basics of Python. It's a very easy, fun language, and if you're also further curious, we teach it here at UCID in the Introduction to Programming unit over at IT. So if you're ever interested in going over to IT, computer science, doing some of their units, Intro to Programming, I believe these days they cover Python. So yeah, if you want to learn it, it's there for you. All right, that's it for this extension video, and I'll see you guys next time.